Hi. Yes, my name is Vasilika Klimova, and a few words about me. I'm from Russia, but now I live in Luxembourg. I have been working as a front-end developer in the company named Artec 3D for 4 years. My tasks includes markup, JavaScript animation, 3D projects, 3D WebGL projects, meetups arrangement, and React framework. Artec 3D, what is the company? Our company creates handheld scanners. Artec Eva, Leo, and Spider are the best handheld scanners in the world. It is using in a lot of fields, like 3D cinema, 3D effects, games, medicine, paleontology, archaeology, NASA, and a lot of different fields. And 3 years ago, we have created the booth. This booth can scan a person in 12 seconds. Okay, today we will talk about what is WebGL. We will talk about basics of 3D computer graphics, and we get acquainted with basics of shading language. Then we see examples of texture filtering. We will know what post-processing and system of particles mean, and how debug WebGL. And where we can use WebGL? Of course, games. Do you love games? I like role-playing games most of all. And the performance of browser WebGL games almost is not interfere to the performance of desktop games. Navigation. We can see this example. This example demonstrates the large round bookshelf. We can choose the book and read its annotation, like this. 3D interaction helps user to get the feeling, the touch feeling when choosing the book. Okay, let's go. Constructors.
Hello and welcome to the all-new...
This example shows you all human body with a lot of details of different systems. You can choose different options and see how it works. And a lot of 3D cuts, like on shape, helps you to create your own model and edit this model. Sometimes even you can animate this model. Okay, next example. Interactive maps. It's interesting. Have you ever seen the Lord of the Rings site with the 3D map? No? It's an interesting site. Because you can see the whole map. It's not about the Lord of the Rings, it's another example. And you can see the whole map in 3D and look in the part of this map in detail, like this. It's like an environment. You inside in these pictures, different pictures. Okay. Panorama. It's interesting because you can see different part of the world, like a Colosseum, like if you're inside, if you are there. Mapbox.js it's a JavaScript library which can help you to render interactive vector maps. Analytics. This example demonstrates us the world, the Earth, and population in different years. You can see how it changes, like this. It's for wow effects on your site, maybe, or very interesting graphics. Even a popular game engine, Unity 3D, port the code to the browser games in WebGL code. Blend for Web. Oh, it's very interesting large scene which demonstrates how some processing works in a milk factory. We should wait when it will load. Okay. This example interesting for us because all this large scene, which you will see, was made in a Blender software. It's open, it's free software, and it was created by a 3D modeler or 3D designer. Okay, we can choose different frames of this process and see how it works. All tubes, all details, you can see. Even how it parked and goes in another. All of this scene is WebGL. And when the scene is created, you can use Blend for Web add-on to the Blender, and then see this scene in a simple HTML page. It's so simple for us. All work was done by 3D designer. Nowadays, React is a very popular framework, and that's why GL React is actual bindings for React to implement complex effects to the images and content of your website. 3D tour. Let's see. You can see a building or flat like this, and you can go inside and see in different position on this. Sometimes even you can walk like a real tour. Okay, and do you recognize this room? Somebody? Big Bang Theory, yes. Excellent. You can go in this room by this link in the right corner, and what you need to create this VR scene. WebGL scene, WebVR API, and classes, of course. And let's summarize. WebGL, we have two standards, WebGL 1.0 and WebGL 2.0 standards. What we need from HTML, it's a canvas tag, just all. If we talk about the first standard, it was based on OpenGL for embedded systems 2.0 standard, and GLSL for embedded systems 1.1 standard. WebGL can render 2D and 3D objects, and it was these standards are developing by non-commercial Chronos Group organization. This is WebGL scene, the simple. Okay, the standard WebGL 1.0 supports in all modern browsers. If you see the green color, it's absolutely supports, and if not so green, it's partial support. Okay, as for WebGL 2.0, is not so good because only Firefox, Chrome, and Opera know how to deal with advanced technology. If you want to know can your browser shows 3D or it can't, you should go to get.webgl.org, and if you will see moving cube, it's all right. Your browser can render 3D scene. Let's recap. What is a WebGL? It's a HTML canvas tag, then a lot of JavaScript code, and a mysterious shading language. This girl, it's an actress, was scanned by our scanner, and for game Beyond Two Souls for PlayStation, if you know. Okay, we should know something about 3D basics. What is it? Okay, let's go. Scene is a container for all objects of our scene. And what we want to see on our scene, we should show and add to our scene. Light. Without light, we can't see anything. It's dark. That's why we should add the light to our scene. And camera. Camera is the eye. It's a position from which you can see the scene, or all scene. And renderer is an object. This object render our scene and update all parts when you change position of the camera or rotate some object on the scene. Mesh. All objects are polygon mesh. It's is the name for this. And mesh consists of geometry and material. Geometry, it's like a vector object, consists of a lot of points. And material, it's like a skin for our object. And texture, if you want your model was with some texture which was maybe like a photo, you can use it and apply it to the material. There are two camera types, perspective and orthographic. Do you see the difference between these camera types? This orthographic camera, all objects, all cubes have the same size. It does not depends on how far away it from you. Okay, what is shaders and why it's so important for WebGL technology? Do you know that GPU is much faster than CPU? When you render the graphics, it's important for us. JLSA, it's like a C syntax. It's similar to C syntax and C language because it has certain types, and it uses GPU processor, GPU resources, instead of Flash technology, which takes only CPU resources. That's why Flash is dead. If you write shader in a JavaScript code, you should use just strings. And runtime compilation, it is a feature of JLSL for browsers. Shader types. We have two kinds of shaders, Vertex shader and Fragment shader. What we have? All objects, as I said before, consist of points. And each point, Vertex shader handles each point separately. And after after the work of Vertex shader, we get primitives. And rasterization happens with these primitives, and each primitives go to the fragment shader. And the fragment shader decides which pixel color we will have in the display. Rasterization. Because vertices are not aligned to the pixel grid, we interpolate the color, the depth, the position, all these parameters interpolates, and then it goes to the fragment shader, and it's decided how deep of the color, which color we should use and apply to this pixel. WebGL have some set of data. We will talk about just primary data types. It is bool. It's like a true or false, int and integer numbers, float at floating point numbers, different vectors, matrices, and sampler 2D. It's for texture. And there are some qualifiers. They can help to decide where you can use this attribute. The simplest one is attributes. We can use attributes inside Vertex shader. And uniforms attributes, uniform variables, you can use in Vertex shader and in Fragment shader. And the most complex varying variables, because you can use it in Vertex shader, calculate some variable, and then use it in Fragment shader. That's all. For rendering scene, we have 4 transformations. Model transformation is arrange object to the world coordinates. Then view transformation, and it's for position of the camera. And then projection matrix, projection transformation, it depends on which camera did you prefer, orthographic or perspective camera. And viewport transformation is rasterization and render pixel on the display. Let's see on the simple WebGL program. Let's try to understand what this program is doing. Okay, maybe some know what will render in the end of this program. You can say me. Okay, we have 2 global variables, V shader source and F shader source. And aside, we should have void main function. It's necessary for the shaders. We have 2 specialized variables, GL position and GL point size. GL position is responsible of the position of this concrete vertex. And GL point size obviously is responsible for the size of this point, of this vertex. And F shader source has GL frag color variable, specialized variable. It's responsible for which color of our pixel will be in the end. And for what we use main function in JavaScript? It create shaders, compile shaders, set our program, and register our WebGL program. And after this, we can draw our what we can draw, our point. I wrote 26 strings for render just one point, one square point. That's why we use Three.js for our task in my team. Three.js can help you use a lot of objects inside this library, and it has good documentation, examples, and etc. Okay, Vertex shader. Notice that if you use this value for the attribute type for script, xshader / xvertex, you should not write shader code in strings. It's more convenient for us. Okay, here we calculate GL position, and each shader was wrote for Three.js. That's why we have already calculated model view matrix and projection matrix and all these complex things. And in the end, we calculate just a GL position for each vertex. In this fragment shader, we calculate GL frag color, and we use for this texture 2D method. This method accepts two parameters. It's texture, and VUV, it's texture coordinates. For decide to which color we should render for in this place for this vertex, we should use texture coordinates. Okay, if you want to do some texture filtering or some transformation with your texture, you should use shader material object from Three.js. You should pass the texture to it and pass shader programs, like here. This is code from script for before sliders, of previous sliders. And in the end, you can get this model with texture. If you want to show your scene or your object in black and white filter, what should you do? I think somebody remembers about CSS filter grayscale, yeah? Yeah. And maybe you think that it's a good idea for this task, but it's not. Because CSS filter can change color for all canvas element. All your scene will be in black and white color. It can choose only one object on this scene. This is problem. That's why we should rewrite our fragment shader. Now, what we should do? We can use arithmetic mean formula here. For change the current color for each pixel, and in the end you will receive the black and white color, but with different hue of this color. And Sepia. Some can use this formula to calculate special factor for sepia filtering. And then with this factor, you can calculate each RGB parameter and get your new color of your model, of this pixel. But sometimes people use more more actual formula for sepia color. And it's a lot. It's not so good for different tasks. Okay. In the end, we can get these tortures. Rendering. We use request animation frame. It's like a set interval method, but request animation frame is better because it reduces CPU resources because browser decided when this animation should happen. Environment. We show the same examples when it's like 3D tour. You inside this cube or sphere, and you can see this like you stay in this point. And how we can do it? In the start, you can use 6 images for make cube. And then we can use these 6 images to texturing each side of this cube. Here in the loop, we can create new basic material and mapping these images to this side. And then, in the end, we can create the mesh and use this material. And this material consists of 6 different materials and cube geometry with 6 sides. And that's all. When you create it, you just put the camera inside this cube and can see all what happens around you. Post-processing. What is this? It is an effect which we can apply to our scene after the scene has already been rendered. How it works? It's just a lot of objects and some noise happens in different moments. And this post-processing. You can do something another with your scene, but we have such example. And in 3JS, you can use effect composer for this effect. And you should pass render to this object. And then you should write your shaders for this effect. It consists of Vertex and Fragment, of course, shaders, and some variables here. And then you should pass this shaders program to shader pass object. And that's all. Then you can add these effects to your scene and set value of property renders to scene to true. And you can see your effect on your scene. When you render post-processing a scene, and if you use Composer, you should animate not only your renderer, you should update your Composer render. In the previous example, we update our renderer. Particles. Particles are the most beautiful, I think, feature and very interesting. Compared to these 2 kinds of the flame. Did you see that left flame? The left flame is more angular, and because it was made by polygons, and we can see angles of these polygons. It's a bad example. And this is example. It's an example of using a system of particles. How we can use particles? Okay, and we should decide which geometry we use for particle. We choose material and position for all this system of particles here. And that's all. The main idea of particle system is that each particle has the same geometry, and it reduces resources for the rendering this scene with particles. It's used for rendered grass or hairs where we can have a lot of objects. And let's see our example. It's really beautiful. A lot of pieces they have geometry, sphere geometry, and they shows you a face of some person, and then they will show you human arms. And it's interesting and beautiful, and uses for stars maybe in your 3D scene. For debug shaders, I think the most convenient tool is a shader editor from Mozilla. WebGL Advantages. You should remember that shaders use GPU performances. We have no compilation for this. It's runtime compilation. And this cross-platform technology, and because we use it in JavaScript, we should not think about memory management like in C languages. And it's an open standard. You can use it absolutely free. And disadvantages, all of this only for raster graphics. Even if you want to show vector object in a canvas, you, in the end, you will see only pixels, and it's about raster graphics. JavaScript can have leak memory. That's why we should optimize our code. And when we have a polygonal scene with millions of points, it can slow down. And for what you can use in your website WebGL. If you want to edit video or raster graphics, some kind of images, if you want to see interactive maps or interactive graphics, interactive statistics, analytics, and of course for games. If you want to write game for browser, you should do it using WebGL. And interactivity and gamification of your site is not a future, it's our present, and I hope I inspire you to make your sites more beautiful and interesting. Okay, thank you for your attention.